this computer. Okay, share my screen. Give me a second to do that. So yesterday we did rotations. That was section 2.4. We got most of the notes done yesterday. I have 2 examples that I need to do with you guys to finish up these notes. And then we'll look at our transformations packet, which is tonight's homework. It's just a review packet of all the different transformations we've looked at so far, which have been translations, reflections, and now rotations. And so this right here was your cheat sheet for rotations. Counterclockwise, we'll start with clockwise. Clockwise, 90-degree rotation. You flip the X, or take the opposite of the X coordinate, and then you flip the coordinates around. 90 degrees counterclockwise, you take the opposite of the Y coordinate, flip the coordinates around. And then 180-degree rotation, you take the opposite of both coordinates, but you don't flip anything around. Okay, just leave them just like they are. So those are the 3 different types of rotations that we have. And so we looked at a lot of them. We did all of them basically. We did the 90 degrees clockwise, counterclockwise, and the 180-degree. We even looked at some of the different coordinates and how it changed the coordinates. So now what I want to do is I want to talk about rotating around the vertex, because we have one homework question, I think it was number 15, that had you rotate around a vertex. Normally we rotate around the origin. So think of the origin as the sun and the points as the planets, right? The farther a planet is away from the sun, the farther it's going to be away from the sun. So like K right here, if I were to rotate K around the origin, would be somewhere around over here, right? But when we rotate around a vertex, no longer is the origin our point of rotation. It's now one of the vertices, which is this one here. Okay, so if we're rotating around a vertex, the vertex that we're rotating around doesn't move. Okay, so it stays put. The other 2 points will in this triangle. And so because I'm rotating 90 degrees, make sure everything makes a right angle. Okay, so let's go ahead. I wish I could tell you that there was a shortcut arrow notation that we could do for this. There's not, because we're not rotating around the origin. So we just have to use our head for this one. We're going to rotate this triangle 90 degrees counterclockwise around vertex P, which means vertex P is going to stay exactly where it is right now and become P prime. Because if we're rotating around that vertex is stationary. It is not moving. So I need to rotate counterclockwise, which means I'm going in this direction. So what was in quadrant 1 is now going to be in quadrant 2. And what was in quadrant 4 is now going to be in quadrant 1. Okay, how do I do it though? Well, here's what I'm going to do. Notice that it's kind of like using the slope here. I had to go up 2 and I had to go right 3 to get to point N. So now what I'm going to do, look a little odd. If I do a 90-degree counterclockwise rotation, I'm going to rotate that 90 degrees. I'm going to go, instead of up 2 and right 3, I'm going to go left 2 and up 3, which means point N is going to be right there, right on the border, right on the origin there. Okay, let me get rid of that. So N prime is going to be right here. So I guess it didn't go to quadrant 1. I was thinking rotating around the origin again. I'm not rotating around the origin. I'm rotating around point P. So there's our N prime. And then our M prime, I had to go right 1 and up 1, 2, 3, 4, 5, 6 to get from P to M. So let me rotate that 90 degrees. Hang on a second. Trying to rotate everything except the blue. I don't want the blue to rotate. Okay, so let me rotate that 90. Ugh, darn it. Oh well. Well, nothing I can do now. Let me try it again. How about I just move you out of the way? There we go. Ugh, stupid. Now let me rotate. Okay, that's going to put our M prime right over here. on that point, which is -4, -2. And so that's going to be our M prime. We have our P prime and our N prime. And now I can draw in my triangle just like that. So this one's better to visualize. Is that right? That doesn't look right for M.
The M's -5,
Didn't it? I was going to say we had to go up 6, didn't we? So we should be going over 6. Yeah, it's in the wrong spot. So if we have to go up 6 to get there, we should be going over 6 now. There we go. Okay, there's our new. So there's a 90-degree counterclockwise rotation around the vertex P. Now, just for kicks and giggles, why don't we do the other ones? Just because I know this is a little bit harder. Why don't we now do a 90-degree clockwise rotation, which means we'll be going this direction. Okay, still around vertex P. So we're still going to make P our point of rotation there. So instead of going right 3, up 2, now I would be going down 3, right 2. Because it's rotating 90 degrees. I'm going to get rid of the P prime, N prime, because it's going to look crazy. Let's just get rid of that. Okay, so there's our new N prime. Instead of going one to the right and 6 up, now we're going to go 1 down and 6 to the right, which is going to put us here at 7. 1, 2, 3, 4, 5, 6. Yeah. Okay. So then let me draw in that triangle. Okay, so there's a 90-degree clockwise rotation. And then we'll do a 180-degree rotation. Okay, so still doing from point P in the middle. 180-degree rotation. Instead of going right 1 and up 6, we're going to go left 1 and down 1, 2, 3, 4, 5, 6. (180-degree) might be the easiest one to think of, to visualize. Okay, so there's our new M prime. And then instead of going right 3, up 2, I'm going to go left 3, down 2. There's our new N prime. And this is going to look like a windmill or a propeller. Because what's a propeller do? It does a 360-degree rotation. So this is the 180-degree. And so that's what it looks like now, with all 3 different transformations, all being rotated around the point P. Because if you think about it, in a windmill or a propeller, the center of it is the point you're rotating around, which is actually part of the propeller. It's always turning. If I was rotating around the origin, like here, the center that I'm rotating around is the origin, and it's not actually touching the triangle, so it shouldn't touch the triangle when I rotate it either. Okay. All right, so we have that. So that should help you with number 15 on the homework for 2.4, if you weren't able to get that one already. And now our last problem is this one down at the very bottom. It says the red figure is congruent to the blue figure. So we know if there was a transformation, it had to have been a translation, a reflection, or a rotation. There was no dilation yet, so we haven't talked about dilations. Describe 2 different sequences of transformations in which the blue figure is the image of the red figure, which means the blue figure is the prime figure. Okay, so the original one is the red figure. So when I'm doing a problem like this, where I'm trying to figure out what are my different steps, like what are the different transformations, the first thing that might be easiest to tell is it looks like they've rotated it, right? So we could start with that. So if I'm starting at the red, what direction do you guys think they rotated it?
Clockwise.
Clockwise, like this? Okay. So let's start with a 90-degree clockwise rotation. And I've written that exactly the way you would need to write it, because if you just put 90 degrees clockwise, you're not telling me that you know it's a rotation. So what I'm going to do is I'm going to plot the points if I were to rotate it 90 degrees clockwise around the origin. Now, one of the points is actually touching the origin. So it's going to stay just like when we rotate. So think about this one as rotating around that vertex, because it just so happens to be that vertex is touching the origin. Okay. So this one, which is 2 units to the left, is now going to be 2 units up. And this point, which was 3 units to the left and 4 units down, is now going to be 3 units up and 4 units to the left. And this one, you could, obviously, it's going to be right there. You don't have to do too much thinking about this one because it has to make a parallelogram, right? But if you wanted to think about it, you'd say, well, this point, which was 1 unit to the left and 4 units, 3 units down, 4 units, I had it right, 4 units down, is now going to be 1 unit to the up and then 4 units to the left. Okay, so this is our new, after the first transformation, after the 90-degree clockwise rotation, that's what it should look like now. Now, since this is the parallelogram we have now, what would you guys say the other transformation was to get it from purple to blue?
90 degrees clockwise.
Nope, not 90 degrees clockwise, because that's going to flip it and make it look like this.
270 degrees counterclockwise.
That's the same thing.
Translate it up 1 and over 4.
It's going to be translated. Yep, it's just going to be translated. We're just literally taking it and we're going to move it. And as Claire said, up 1 over 4. Right? Okay, so I'm going to write that down. Translate, or trans if I want to abbreviate it. We did up 1. And then you said over 4. What direction was that, Claire?
Right.
Right 4. All right. So that's one sequence of transformations, and it obviously works. And it definitely helps to draw in the in-between shape, right? The in-between image. The single prime image. This one's technically, the blue one's technically the double prime image, because it means there's been 2 transformations. But there's another way you could do this one. Because, and the reason you can do it 2 ways is because this is a parallelogram. Okay, so let me go ahead and erase I won't erase the blue one, or the purple one. We'll leave the purple one there. I'll just use orange. Because this is a parallelogram, I could actually rotate it 90 degrees counterclockwise, and it would still fit that description of what that parallelogram looks like. So what if we did a 90 degrees counterclockwise rotation? Well, we'd be rotating around the origin. So this point here is not going to change. I feel like it keeps moving my thing around. My pictures are copy and pasted. So every time I try to write on them, it just wants to move the picture around. Instead of going 2 units to the left, we're going to go 2 units down. Instead of going 3 units left and 4 down, we're going to go 3 down and 4 right. 3 down, 4 right. Instead of going 1 unit left and 4 down, I'm going to go 1 unit down and 4 right, which you could figure that one out on your own because it has to be a parallelogram. So if I rotate it 90 degrees counterclockwise, it still fits that description of, because it's a parallelogram, right? If it was a triangle, this wouldn't work at all. If it was a triangle, it just wouldn't work.
And then you would translate it up 4, right?
Just up 4? I
Yep.
think that's right, because it looks to be lined up perfectly, right?
Mm-hmm.
Just go up 4. Yep, that would work. So my second one is going to be a translation of just up 4. There. Questions on that? Do you guys see how there was? Now, I'm not going to ask you on a quiz to give me 2 or 3 or 4 different sequences. All you need to come up with is one. So if you can figure out one way that gets you from the red to the purple to the blue, or from the red to the orange to the blue, then that's all you'll need to be able to do. But when you're looking at shapes like this and you're trying to think out, like, instead of trying to guess how far it was translated, it might not even be translated at all. If you know it's been rotated, start there. If you know it's been reflected, start there, and let the translation be the last one. So once I rotate it, then I can slide it to where I need it to go. So always let that translation be the last one. Okay. All right, so that's it with the notes. Yeah. So what you guys are going to want to review to make sure you're ready for Friday's quiz is you're going to want to know your translations cheat sheet. That's the easy one. Move it to the right, add to the X. Move it to the left, subtract from the X. Move it up, add to the Y. Move it down, subtract from the Y. Okay, know your translations cheat sheet. Know your reflections cheat sheet. X-axis reflection, take the opposite of the Y. Y-axis reflection, take the opposite of the X. Y equals X reflection, flip-flop them. And then know your rotations cheat sheet. 90 degrees clockwise, opposite the X, flip them. 90 degrees counterclockwise, opposite the Y, and then flip them. And then 180 degrees, opposite of both, do not flip. Okay, so that's, if you can do that, if you can do the arrow notation, you'll be ready for Friday's quiz. Because even if I give you a coordinate plane and say, I need you to go ahead and rotate this one, if you can write the coordinates down and then draw the arrows and know what they're going to become, then you can just plot the new prime coordinates and be done. You don't have to visualize any of these, as long as you know what's happening to the coordinates each time. Okay, so make sure you know that going into Friday's quiz. To help you study for Friday's quiz, we have 2 review days. Today's one of them. So to help you review, we have the transformations packet. This is posted on Google Classroom to this assignment, so make sure you download it. You'll have to do it on Notability because we're at home and paper copies are worthless at this point. And actually, it might be better to do a Notability, because if you make a mistake, you can just maybe even, like, if I draw the wrong triangle, I could, like, literally move it over. If it's a translation, right? It's pretty simple. So it might be helpful to do it on Notability versus doing it on paper. The first page, which says Practice A, is translations. So they just want you to, in the coordinate plane, actually, hang on a second. No, it's got all of them. Okay, I apologize. It's got all of them. So the first 2 questions are translations. I just need to draw the triangle or the rectangle in number 2 to where it's going to be translated to. You don't have to label the points if you don't want to. You don't want to put F prime, G prime, J prime, H prime, A prime, B prime, C prime. That's okay if you don't want to write that. I just need the triangle. 3 and 4 are reflecting across the x-axis and y-axis respectively. And then number 5 and number 6 are both rotations. Now, I'll be honest, with 5 and 6, if you have a hard time visualizing it, then write out the coordinates and use arrow notation to tell what the new coordinates are going to be. Okay, if you have a hard time visualizing it. Number 5 is going to be pretty easy because we just did one like that on the notes, right? We're actually rotating around Q because Q is right on the origin. For number 6, the more you do these rotations, the easier they become. If you want to rotate this 180 degrees around the origin, instead of going 2 spots to the right, 1 spot up, go 2 spots to the left and 1 spot down. Remember, the X and Y just, you don't flip them, but they just become opposites of each other. And so you don't actually have to use arrow notation. The better you can be, the more rotations you do, the better you are at visualizing what they look like. And then you can stop using, well, I won't say stop using arrow notation because I'll have to ask you to do it on the quiz, but you wouldn't have to do it if it's not asked for it. Like, it doesn't ask you in number 6 to use arrow notation, so you don't have to if you don't want to. Okay, but it's always there. It's always there to help you if you're stuck.
So he wants to do the whole thing.
I want you to do the whole thing, the whole packet. Yes.
Oh.
Yep. And so there's 7 problems on the first page, and the first page just tells you, it just gives you coordinates and then asks you what kind of transformation it was. So was it a translation? If so, write it down and tell me if they moved it up, down, left, or right. If it was a reflection, make sure you write that down and tell me what axis they reflected over. If it was a rotation, make sure you write that down and tell me how many degrees and which direction they rotated it. Okay, so you can tell from the coordinates, just like we did when we did problems like this. So all I need to do is I need to focus in on one set of points. And if that doesn't help me, focus in on another set of points, the y to the y prime. Okay. Now, when I'm doing my transformations, I know that a rotation and a reflection will not change the number. It might flip their spots. It might make one of them negative, but it doesn't make it -7 to -1. The only thing that can do that is if you add or subtract. And what kind of transformation add or subtracts to the coordinates?
Translation.
A translation. Thank you. Yeah, so this has got to be some type of translation. Because again, if it was a rotation, things would have been flipped. Reflection, one would be opposite, then the other one wouldn't be opposite, right? So like the fact that the numbers are completely different means that they would have added or subtracted here, and that makes this some sort of translation. You just have to figure out, what did they add or subtract from the X? What did they add or subtract from the Y? Because that's going to tell you whether it moved up or down or left or right. All right, second page. Again, translation, translation, reflection, reflection, rotation, rotate. Apparently I've got some answers here that I don't want to give out. All right, so then we have number 7, which is again asking you what's happening to the coordinates. Third page, translation, translation, reflection, reflection, rotation, rotation. Then it's giving you coordinates and it wants to know what happened, what kind of transformation was it, be specific. I'd like to focus in on the last page here. The last page is going to give you, it's only 4 questions, but it's giving you a series of transformations. So let's look at number 1. Identify the combined transformations from the original to the final image and tell whether the 2 figures are similar or congruent. Okay, they're all going to be congruent. Let me save you the time. We haven't talked about dilations yet. So they're all going to be congruent. You don't even need to write it. I'm just telling you they're going to be congruent. I don't think there's any dilations on here. No. Okay, so for number 1, how can I tell which of these triangles is the original?
The triangle that doesn't have any primes on it.
You got it, Elise. Nice job. It'd be the triangle with no prime. So this was the original one. I'll put O in the middle of it so we know it's the original. Okay. That makes the single prime. Okay, that's going to be your first transformation, and then your second transformation is going to be the double prime. So knowing that that's the order, can you guys tell me what transformation did they do to get from the original?
180 degrees.
Not a 180. From the original to the first prime.
90 degrees.
Reflected.
Not 90
They
degrees.
reflected over the x-axis.
Yes, it's a reflection. You got it. It's a reflection over the x-axis. This shape, they're just reflections of each other. Okay. And I know it's not a 90-degree rotation, because if it were, the B would be rotated somewhere over here, and the A would be rotated somewhere over there, and that's not the case. Also, you can tell the A is 4 units up, now it's 4 units down. C is 2 units up, now it's 2 units down. So this is totally a reflection. And so I'm just going to write reflection, or I'll abbreviate that, reflection over the x-axis. That's all I have to write for the first one. Now, to go from the single prime, I'm not going from the original to here. I am not doing that. I'm going from the single prime to the double prime. So what kind of transformation would take me from there to the double prime?
A rotation
90 degrees.
90 degrees.
You guys got it. Yep, a rotation of
90.
180 degrees. That means the A goes all the way over here, the B goes all the way over here, and the C goes all the way over there. They get rotated 180 degrees. Good. So that's pretty easy, right? That wasn't terrible. They gave you the middle image, so you knew if they gave you the single prime image, you knew what was going on. So let's take the training wheels off and look at number 3 then. They give you the original triangle. Oops, right here. And then they give you the double prime triangle. They don't give you the single prime triangle. So I have to think about what's happened here. I still have to list 2 of them. Okay. Let me ask you this. If I gave you $100 and you were making a bet, what transformation are you absolutely positive has happened here?
Rotation.
Okay, let's start there. That's always where I'd like to start. Maybe it's been moved, maybe it hasn't been moved, but we know it's been rotated because it wasn't reflected, at least not that it looks like. So let's start with the rotation. Caleb, what kind of rotation are we looking at here?
90 degrees.
90 degrees.
Counterclockwise.
Counterclockwise. Okay, so rotation 90 degrees counterclockwise. I did not have to write the direction when I do 180 degrees up here because it doesn't matter the direction. 180 degrees just halfway. So now what I'm going to do is I'm going to plot where the triangle would be now. So I'm going to plot the single prime triangle after I do a 90-degree counterclockwise rotation. So again, you can use arrow notation if you want. Arrow notation is the safest way to do it. I'm going to be a little bit risky and see if I can do it in my head. Instead of going down 1, right 4, I'm going to go over 1, up 4. B prime is going to be right there. Instead of going, use the pointer, down 3, right 4, I'm going to go over 3, up 4. C prime is going to be right there. And that makes sense because C prime and B prime were connected to each other with a straight line. So that makes sense. Instead of going 1 to the right and down, let's do the down first. Instead of going, the reason I like going up or down first is because the coordinates are going to flip. So that becomes your X. The Y becomes your X. So down 3, right 1 becomes over 3, up 1. Okay. So that's what it looks like after we do so the first thing you're going to want to do, like I mentioned, is write down the transformation you're absolutely sure has happened. And then what does it appear that's happened from the single prime to the double prime?
The translation?
Yeah, translation. Good. So we got a translation here. And then an easy way to get a translation wrong is if you try to go like this. Okay, when you're doing a translation, make sure you go from one coordinate to the exact same coordinate on the other one. So if you want to look at the B prime, for example, you're going down 3 and then left 1, 2, 3, 4. Okay, so go from B to B, or go from C to C, down 3, left 4, or go from A to A, down 3, left 4. So I'm going to list the left one first because that is my, what did I do for left? LT, I think I did. I'm just going to write left. Left 4, and then down 3. I would even accept it if you went like this, x minus 4, y plus 3, because that tells me what you're actually doing to the coordinates. I would accept either one of those. Okay. Number 2 and number 4 are going to ask you to write the coordinates of the image. So instead of giving you a graph and asking you to tell what the transformations were, they're telling you what the transformations are and asking you to tell what the new coordinates are. And so this is where I'd want to use arrow notation, because it's hard for me to memorize all the coordinates after the first one if I don't write them down and then know them for the next one. Okay, so let's look at number 2. I'll let you do number 4 on your own. The coordinates were -3, 1, -1, 5, and 1, 1. The first transformation we have here is a reflection across the y-axis. Can someone please tell me what that does to the coordinates?
It takes the opposite of the x coordinate.
Okay, does it flip them, Nuche?
No.
You're right, good. So I'm going to write -x, y to show that they were not flipped. I'm just taking the opposite x. I only need to write that on the top arrow. Okay, so I'm using arrow notation for number 2. I'm going to use arrow notation for number 4 as well. So when I do that, that's going to give me +3, 1, +1, 5, and -1, 1. And so again, I don't care if you write A, B, C, A prime, B prime, C prime. I'm not gonna dock you on those if you don't. But I do want to make sure you have the right arrow notation on the top. The second transformation is a 90 degrees clockwise rotation. So someone other than Nuche, tell me what happens to the coordinates for a 90 degrees clockwise.
The y is negative and they get switched.
You got it. The y becomes negative and they're switched. So I'm going to make the y's negative. I ran out of room here, so I'm going to, another reason why using Notability is helpful, slide this over a little bit. So what are my new coordinates then? You guys help me. Let's finish this. What's my final answer here?
-1, 3.
Good. Next one.
-5, 1.
Good. And the next one?
-1, -1.
Got it. So technically, this is my answer, but I want all of it.
Okay.
Right? I want all of it. I want to know what the in-between points were. I want to know what you did both times. I want all of that stuff. And so I want number 4 to look the exact same way after you do those 2 transformations, except number 4 is going to be even easier because they're only asking you to do 1 point instead of 3. So it's going to be a third of the work. Does anyone see any questions that they might have on any of these packet questions? And it's a packet because it's more than 1 page. It's technically 4 pages, or 2 pages double spaced is what it would have been. Does anyone have any questions that they see?
On that problem, the one that we just did,
Yeah.
if it was a clockwise rotation, wouldn't the x be negative?
Yes. Thank you, Claire. Yeah, I didn't even notice that. For whatever reason, when Caleb said that, I was like, yeah, sure, it says clockwise. It does not say counterclockwise, it says clockwise. So yeah, we need to back up just a second. Yeah, I didn't even notice that. Yeah, so it's going to be -x for our clockwise and then flip them. So y comma -x. So the x that we just made negative in the previous one, we're going to make it the opposite again. And so it's going to be back to -3, but it's going to be 1 -3. And 5 -1. And 1 1. Thank you for that. Yeah, so now I've got everything that I need. Yeah, that's important. I'm glad you pointed that out because I don't want to do the other transformations wrong on problems 5 and 6 on the other pages. Okay. Anyone else have any questions, or did you catch me in another mistake somewhere? Okay, well, our lesson is over. If you have questions over this packet, or if you have questions over the 2.3 homework that's due today, or the 2.4 homework that's due tomorrow, let me know and we can go over those, okay? Take it easy today, guys, and hopefully, fingers crossed, we're back in school, maybe with a 2-hour delay. That'd be helpful. So, well, I don't know how helpful it'd be, but it'd be nice. So, let me know if you have any questions, and I'll see you guys later.